Disclaimer. The views expressed in this video reflect the opinions of the creator and may not align with widely accepted beliefs. Viewers are encouraged to consider multiple perspectives and conduct their own research before forming conclusions.
Hello and welcome to another video. As I've discussed in previous episodes, I believe the JED pillars functioned as 3 coil arrays, designed to transmit electromagnetic waves for both power and communication. If my interpretation is correct, then we should expect that their technology would have continued to evolve, leading to a diminished reliance on large, bulky coils, just as ours did. This appears to have been the case, and evidence of this shift seems to be reflected in their art. The JED pillar, once a prominent symbol, was eventually replaced by these objects. At first glance, they resemble a lotus flower, a vase or pedestal, and a teapot. Quite often, bird-headed humanoids with suns and snakes atop their heads stand nearby. Given this symbolic complexity, it's reasonable to assume that these representations shouldn't be taken at face value. After all, what need would the sun god have for a teapot? If the lotus flower and vase combination replaced the JED pillar, and assuming the JED was used to amplify and transmit electromagnetic waves, then its successor would likely serve the same function, but more efficiently, more powerfully, and in a more compact design. The technological trajectory they were following would have naturally led to vacuum tube technology, ultimately culminating in the development of klystron-type devices. A klystron is a vacuum tube that generates and efficiently amplifies microwave signals. There are several different types and many different designs of each type. In our timeline, the evolution of klystrons can be traced back to early light bulb experiments, when Thomas Edison observed that heated filaments could emit electrons into a vacuum, a phenomenon later termed the Edison effect. This discovery led to the development of vacuum tubes, which became fundamental to radio and electronics. Building upon these principles, Russell and Sigurd Varian invented the klystron in the 1930s. Unlike traditional vacuum tubes, klystrons utilize resonant cavities. Thus, the study of electron behavior within vacuum environments, first explored in early light bulb experiments, eventually laid the foundation for advanced vacuum tube technologies like the klystron. As mentioned in episode 7, one of the Dendera lamps exhibits a characteristic unique to filament lamps. If this observation holds, it is reasonable to suggest that the ancient Egyptians may have made similar discoveries to Edison and experimented accordingly. Klystrons require extremely precise engineering to function effectively. Since they amplify microwave frequencies using resonant cavities, even minor variations in cavity dimensions can significantly affect performance. Small imperfections can lead to signal distortions, reduced efficiency or frequency mismatches, making precision manufacturing and calibration essential. Let's examine the units in more detail. If we start with the main component, I believe it represents a drift tube assembly. The horns at each end of the tube function as waveguides or RF couplers, facilitating the transmission of waves into and out of the tube. Here's what they typically look like. A drift tube in a klystron is an open space where electrons travel without interference, allowing them to bunch together before transferring energy to an RF signal. This makes it a crucial component for signal amplification. Drift tubes are also present in linear accelerators and traveling wave tubes. I believe the teapot-like objects in the artwork represent resonant cavities. These cavities come in various shapes, though they are generally cylindrical. Resonant cavities are essential for modifying microwave frequencies, as they select and reinforce desired frequencies while suppressing others. Their dimensions determine their resonant frequency, meaning changes in size or dielectric materials can shift their operating frequency. Interestingly, external cavities can be coupled to a klystron via electromagnetic fields without requiring a physical connection. This can be achieved through waveguides or resonant coupling, allowing an external resonator to interact with the system indirectly. Sometimes these teapot-like objects feature spout-like appendages, while others do not. I suspect these spouts symbolize waveguides, which can be straight, bent, or twisted. Here are some examples of their typical shapes. That leaves us with the lotus flower, which I believe represents a horn antenna. Here's what those look like. A horn antenna is a flared, directional antenna that efficiently transmits or receives microwave signals. Notice how the ridged fins inside the horn contribute to their flower-like appearance. If you recall the video I made about Thoth's beak, I examined the so-called trumpets that were found amongst King Tut's treasures. Personally, I believe these were waveguide and horn antenna combinations. Their material and dimensions make them suitable for microwave frequencies, but that topic deserves a deeper analysis in another video. Notably, the horn structures were artistically decorated to enhance their natural resemblance to lotus flowers. I suspect the same artistic philosophy was applied here. In other words, I believe the lotus flowers in these depictions are actually horn antennas that had that resemblance artistically enhanced, both in real life, then again in their rendering. Another intriguing observation is the placement of the lotus stalk in the artwork. It would have been easier and more accurate to depict the stalk emerging from the vase, as would be expected for ordinary flowers. Yet artists consistently depicted the stalk outside the vase, every single time. Additionally, the flower always points toward the central figures in the scene, never toward the individual with raised hands. Recap and conclusions. I believe the depicted components correspond to a drift tube, a resonant cavity, a waveguide, and a horn antenna. With these components, you have the key building blocks for a microwave amplification or transmission system. For example, you could construct a basic klystron amplifier, where the drift tube facilitates electron bunching, the resonant cavity controls frequency, the waveguide directs the microwave signal, and the horn antenna efficiently radiates the energy. Alternatively, a microwave communication setup could be designed, where the waveguide and horn antenna serve as transmission and reception elements. And that brings us to the end of this interpretation. What do you think? Did Ra's rider include a pot of tea and a nice flower? Or is this something else?